divided by e to the negative 50 over 0.00831 times 310. Can you solve for x?
No.
Yeah.
Now, does anybody have any questions about this? Praki, is that what you had? Or the other way around?
Yeah.
You did the other way around. I don't think you can neglect that denominator on the power on it. I know that the common vote. What? Because it's an exponent. Not being multiplied.
I'm right?
Yep.
I don't care what you say.
And
You're right. You're right.
change the Celsius to Kelvin.
320.
Number 92 is one of the assigned problems. So I didn't want you to calculate because you can do that on your own. Thanks. Getting the setup is the most important thing. That does it for everything new that's in the chapter. Hopefully you're going to get to those problems and conquer them. I do want to take the last 8 minutes or so of class and talk about the lab tomorrow.
Should I still record this?
Keep recording that. We've got to talk about the lab. Now the lab is going to involve this reaction. Now, let me have your attention. Artea, Prakya, I want you guys to listen to this because there's a lot going on in this lab. Don't let your mind wander. Tell your Facebook friends to hold off for about 10 minutes, okay? Because you'll see how muddy this gets. Your reaction is a simple reaction. It's a redox. You have iodide ion from potassium iodide added to ammonium. This ion right here is an unusual one. It's ammonium persulfate. It's a polyatomic ion that you probably haven't seen before, persulfate. And the iodine is going to oxidize to I2. And then you get the sulfates at the end. This reaction produces iodine. Now we're going to track the reaction by adding a little bit of starch. Now when you're in biology class, you probably learned that when starch is a good test for iodine. Iodine turns like a dark blue color for starch. You remember doing that?
Yep.
Hopefully.
Right.
Yeah, it's a bio thing. Now we're going to use it in here. This is not going to make any color in starch, but as soon as you get I2, it turns blue. If we were to run this reaction, just adding a little bit of starch to this and then adding that, the solution would turn blue within a second. It happens fast enough that we have a hard time tracking how, like, if you want to start a stopwatch and then stop it within a second, that's not enough reaction time for our body, for our brain. So what we do in this lab is we slow the reaction down. And what we're going to do is we're going to add sodium thiosulfate before we start. So you're going to measure out your iodide ion. Then you're going to add some sodium thiosulfate. They don't react with one another. You're going to hold off on adding this until you're all ready. Now here's what's going to happen. The thiosulfate, affectionately known as the clock. Thiosulfate is going to serve as a chemical clock here to slow the reaction down. So we're just going to measure how long it takes for the clock to run out. Okay, now here's what it looks like. The thiosulfate, during this reaction, so you're going to have this thing with the thiosulfate in there and iodine, all those are together. Then you add the persulfate, then the reaction starts. These two things are reacting with one another and producing iodine. The thiosulfate, the clock, is going to take that iodine that's made and it's going to gobble it up and react with it and reduce it back down to I negative. So it doesn't ever build up and turn blue until the clock runs out. So when this stuff runs out and it is all used up, then the iodine builds up and it turns blue on you. And so we're going to use the exact same amount of this clock every time. The one thing that you need to do in this lab is measure carefully. Don't trust your lab partner. Check the measurements for everything that you do in here. You know not to trust your lab partner, right?
Yeah.
Yeah. Yeah, I see you looking around the room. You can't trust those people. So, and that's what this is saying down here. Once you've run out of the clock, then the blue shows up. You immediately stop the watch that you're using. Yeah. So you start the watch when you add that persulfate in, and you stop it as soon as it changes color. And some of these are going to take literally a couple of minutes. for the clock to run out. Now the next, let's see. I'm going to show you what the reaction looks like, and then I'm going to show you what the 4 trials are going to look like. This lab, as I mentioned, is not going to have a write-up. It's going to be due tomorrow afternoon. So you're going to get a handout for this thing. You just have to fill in the blanks in the handout. So I have all the reactants up here. I have my potassium iodide, the first reactant. I'm going to measure out 10 ml of my 2 reactants. There's that, my persulfate. I'm measuring everything out before I do anything. Oh, it's a little bit too much. And then the clock, I'm going to use only 5 ml. Okay, so what we're going to do is we're going to add the potassium iodide first to our flask. The reaction is going to go on in this flask. Everything's going to be added here eventually. Add the clock, because remember the clock doesn't react until you're producing I2. So this is just there, not doing anything. Add your starch. Don't forget the starch. There's going to be a beaker of starch at every station. The starch is, yeah, it's odd. The starch is odd.
So cool.
The starch is going to be like your nose when you get a cold.
Oh,
Sorry.
Good.
Yeah, you're just going to add a drip of starch, however much. Woo! There we go. So I've got everything in there except for my persulfate. My timer is ready with my partner, and they say go. And so I add this, and you may have seen a flash of color at the beginning, did you? You may have, I did. So we swirl.
Are you serious?
And we wait.
Minutes?
What?
You swirl for minutes?
Oh, maybe a couple.
Oh my gosh.
So you could just let it sit if you want to. Just make sure it's swirled well, and then you can set it down. Or if you want to be one that feels like they're in control, then go ahead and keep swirling.
Better to feel in control, guys.
So we watch and we wait and we're timing and we're swirling.
Wait, who's timing?
Clearly.
Your partner. We're not actually timing this one. I just want you to see what the reaction looks like, and I want you to get a flavor for. Oh yeah, this does not happen very fast. Keep watching though. It's good when it happens. It feels like it, doesn't it? So you keep swirling, you keep swirling. We're just waiting for that clock to run out.
You're not gonna make it.
Right now it's gobbling up the iodine. Oh, don't go anywhere. Clock ran out. You hit the timer when you see that blue. Isn't that a pretty blue color?
That's
like
Black.
green.
Yeah, it does change to a deep green color after some time. It's nice.
It's black.
It's
All right, now before you leave, this is what the reaction is going to look like. I know this is crazy looking. I'm going to give you a handout tomorrow that has all this on it. So don't worry about taking pictures or whatever. You'll have this. This just remember, we're trying to find a differential rate law, so we need rate versus concentration data. We need to vary the concentration. That's what's going on here. Yes, ma'am.
You know, like